In the next part of our subdivision design here, we're going to work on sloping the underground utilities. Once you have the sizes, you can figure out slopes and manhole drops and what's needed to have everything flow properly, but we're not going to worry about sizing the underground utilities. We're just going to go with what we have, and we're going to start from the bottom and work our way to the top as we slope these based on the tie-in. So the first thing we're going to do is we need to know the tie-in elevation that the city has given us for our utilities. Now, we don't actually know any of that information here. We're just going to go and type some stuff in and make sure everything works. But the similarities will be there between what the city gives you and what we're doing now. So my very first manhole, my sanitary one, I'm going to go to structure properties. And again, as I've stressed before, name everything. Name everything very descriptively. Name it so it makes sense to you. I'm just going to call this sanitary manhole 1. There's 2 tabs we need to look at after we've named it. There's part properties and there's connections. So under part properties, this will tell us the surface elevation at the insertion points. So my surface is 1,131.547 meters above sea level. It's attached to my lock grading surface. It's referencing my main through road. Now, if you don't change your alignment while you're designing these, you will have to come into each and every single one of these and change it one by one. Rotation angle, northing and easting, just some general information from the drawing. Insertion rim elevation, so this should match the surface elevation. And do we want to adjust it based on the surface? Usually when it's in a road, no, we want it flush with that surface. Sump depth. Now, sanitary manholes, storm manholes do not have a sump in the bottom. What this is an additional area to store liquid. We do not want that sticking around in the manhole. We want anything that flows in to flow out. Where this does come into play is if you have a holding manhole or for our catch basins. We want a bit of a sump in the bottom. We could do the known flow. We can set all this this information up, but for this we're just going to not worry about that. Rim to sump height, so from top to bottom, right now this is 3.8 meters tall. Information from our manhole itself. However, I want to look under the connections tab. Knowing that the surface was 1,131.547, I'm going to type 1131.547 just to remember that number. However, this will not be my invert elevation. I'm just going to pick a number. We're going to say we're going to drop it by 5 meters and have that invert 5 meters deep. So 1126.547. Now, we have invert elevations, we have centerline elevations, we have crown elevations. These other ones will come into play when we get to the next manhole. It also tells you the slope of the pipe. However, you cannot change it in here. We have to change it through pipe properties. So I'm going to remember my 1126.547. I'm going to hit OK. I'm going to select my pipe, go to pipe properties, and again, name the sanitary pipe 1. These are the only 2 I'm going to name just to speed this video up, but go through and name your entire system. So knowing that my start invert elevation is 1126.547, my end invert elevation is the one I want to go to. I want to slope my pipe up. So starting at the lowest point, we want positive slopes. I'm going to type in 0.8%, I believe, for this one. And again, the design guidelines will tell you your minimum slopes. We're just picking some numbers here. So I'm going to change my pipe slope holding the start. Start invert, this is the one I set up. This is the one I want to hold. So pay attention in here, whether you want to hold the start or hold the end. I'm going to hit apply. And we see the end invert is now 1127.101. I'll hit OK. I'll go to my next manhole, structure properties. And we now have 3 pipes connected to this. This is another thing where Civil 3D displays what you're clicking on. So So if I click on this, it's my pipe to the left. If I click on this one, it's my pipe to the right. If I click on this one, it's my pipe to the top, the north. So my pipe from the left is coming in 1127.101. When we have flow pass through a manhole, we don't just match all the inverts. So I would not do this. It may seem like it's okay. However, you got a pipe coming in to the right at 1127.101. You got a pipe going up from the left 1127.101 with a 0% slope in between them. So the way we handle this, where I live in Calgary here, is we have what's called a manhole drop. So the pipe coming in, depending on if it's 0 degrees, if it's straight in, if it's between 0 or 1 and 90, it'll come in at a different elevation. If it's between 90 and 180, it will come in at a different elevation. So all that means is this pipe is straight in, straight out. So the pipe out to the right will be 0.03 meters higher. So this will be 127.131. We have a 30 millimeter drop, a 3 centimeter drop in that pipe. The pipe to the north, now this one is 90 degrees, so if it's straight in is 0.03. If it comes in and out somewhere in this 90 degrees, so here to the left, it's 0.06 drop. So my pipe to the north will be 1127.161. If the pipe happens to come in from over where my mouse is into the manhole and out to the left, that is between 90 and 180 degrees. We need a 150 millimeter drop. So we would change this number by 0.15. So again, remember these numbers, 1127.131, 1127.161. Because when we go into the next pipe properties, we have 1127.131. We want to change the start invert by we want to change it to 0.8. Same with this one here. Pipe properties, 1127.161, 0.8. This also helps that when you've drawn it, you've toggled either upstream or downstream. Upslope, downslope. So you know where you're starting, you know where you're ending. So I'm going to go through this next manhole, structure properties. And if I click here, 1127.800, this will be 1127.860 because it's a 90 degree bend to the north. We'll go structure properties, or pipe properties, sorry. And we'll change this last one to 0.8. Now, we haven't seen anything happen because we've only been working on a plan view. We can put these into our profile views now. Do not select similar for these. If you select similar, it's going to add every single pipe to every single profile and you're going to wind up confused. I'm going to select my manholes for my storm and my sanitary. I'm going to select all the pipes along this main road for my storm and my sanitary. And finally, I'm going to select these. I'm going to right click, draw parts in profile view. I'm going to make sure I select my main through road and we'll click. Civil 3D will put them in here. Here is our storm or sanitary, which we've sloped in. We haven't worried about storm yet. Let's now go and select these pipes going into our cul-de-sac along with these manholes. We're going to add them into two profiles, not the label. Draw parts in profile view, and I'm going to add them into my cul-de-sac entrance road. Now, technically, we should have additional alignments and profiles for the fact that we cannot see the structures on this. I don't even think we can go to profile view properties and tell this to be minus, we'll say 50, and have those show up. Yeah, we can't even do that because they are not on the alignment itself. If we extend this alignment, because it's attached to our road, it's going to cause a problem. So generally, we have alignments for our corridors, and we would have additional alignments to show our drawings and to show our pipes and our utilities in. We can also go into pipe properties and change the information through our profile views as well. So again, this can become a little bit difficult when you can't see things. However, in this case, we have access to everything, we see everything, and we can continue modifying from there. So again, the steps would be the same for your storm as well. We would have a tie-in from the city. We would slope these pipes. Because they're bigger pipes, we can go at lower slopes. We'd slope it into this manhole, say 0.4% from there to there. And let's go ahead and do this one too. So structure properties. The surface is 1131,587. Just 1131.587. Now, the thing with storm is it can be shallower than sanitary. So having a storm system 2 meters deep, 1 meter deep is not out of the question. I believe 1.2 is minimum here in Calgary. However, if you see 1.5 deep, that is fine. If you see 3 meters deep, that is fine. We're going to set this for 11. We'll set it for 1127 just so it's 1 meter above the sanitary. And I'll hit OK. And then I'm going to go change these to the profile view so we can see it happening here. So pipe properties. I'm going to change this to, we'll just do a 0.25 slope. We'll do something smaller. Now another way we can set our inverts up is you can use these grips. You can come into your profile and type things. So knowing straight through the manhole is 0.03 drop, we do have to pay attention to the vertical exaggeration of our profile. So this is 10 times exaggerated. Yep. So 0.03 drop, we can just grab this and move it up 0.3. So that is another option available for you for doing these. However, structure properties is probably always the easiest way. And as we have 5 pipes coming into this manhole here, it might be a little easier to do this through plan view. So structure properties. This is the pipe coming in, so we have 1127,755. This is the pipe going out, which is 30 millimeters higher. The pipe to the north will be 1127.755 plus 60 millimeters. So this will be 815. I'm just going to check my math here. Yeah, so 815. The pipe going to the north. Now, when it comes to catch basin leads, we don't change them from this window. We change them from our structure properties. So I'm just going to move these labels out of the way so I can access my structures. So structure properties. This is 1131.213. 1131.213. And the pipe comes out of the catch basin 1.2 meters below ground. So this will be 1130.013, I believe. That should be 1.2 meters deep. So I'm going to hit OK now. Go into my pipe properties. And just to make sure our rules, minimum cover is violated, but let's slope it first. So 1130.013, I want minus 2%. I want from the manhole to the catch basin at minus 2%. If I hit apply, and we look at our rules now, we're still violating our minimum cover because we did not change the crown elevation. We want this pipe 1.2 meters deep. So 1131.213, come into here. This should be 1130.013. And because of the way the curb and gutter is situated, I'm going to drop it an additional 10 millimeters. And we'll see if that helps us meet minimum cover. I'm going to come in here, change this back to minus 2%. Our rules, minimum cover is 1.2 meters. So this pipe starts 1.2 meters below ground and slopes to the manhole at 2%. We do not have to worry about any manhole drops because theoretically these pipes will come in higher than the outgoing pipe. So if I just draw this in profile view quickly, our pipe up here comes in well above these ones. So again, there's a lot of back and forth. There's a lot of changing things. Setting your slopes up, making sure everything is correct, ensuring that all the water flows downhill. We definitely need to use critical thinking here because we need to make sure that no pipes are interfering with no other pipes. So when you're done sloping all these, we need to check any interferences. Make sure that, for example, this sanitary pipe is not going through this storm pipe. And if we look at this connection right here, this red pipe is the one coming in. It is, measure a distance here, 3.481. So this is about 348 millimeters below this. This pipe is below this one by about 348 millimeters, so which is about a foot. This will be the only spot in our subdivision where the pipes would actually interfere. However, if you have a larger subdivision, you're going to have more crossings, more interferences. And it's not just the storm pipes that we have to worry about. It is the water pipes as well. So when we get into the pressure networks, we're going to see how those interact. And how we can make those go up and around and do specific things for us. So again, just to finish this off quickly, 1127.8. Pipe going out is 1127.86. Which, oh, I was clicking on the wrong manhole. Okay. Again, sometimes it's easier to do through your plan view because again, we have more manholes here or more pipes coming in. So that is 1127.944. The one going out should be 1128.024, or sorry, 054 because it's 60 millimeters higher. We'll do pipe properties, 0.25%. Again, you'll get the numbers from your design guidelines as well. So I've got all these pipes sloped. I've sloped this catch basin. You would slope these ones as well. Time into the surface, 1.2 meters down, 2% to the manhole. You'd work your way up into the subdivision as well. So once you have all your pipes sloped, we can look at changing these labels. And again, it's just a quick label properties. And we will choose our all info plan labels. So this will tell us all the information. It'll tell us the structure name, the rim elevation, the northing and easting, the east invert. And you can make these say east in, east out, west out, etc. It's just in the label style. And the sump elevation. So we want to confirm the lowest invert is the elevation of the sump that Civil 3D has. When it comes to your catch basins though, all info plan labels, this sump should be a meter below the lowest invert. So my invert is 1129.753. My sump is 1128.753. We have about a meter in the bottom of these catch basins to hold debris, to hold sticks, to hold rocks. And it's easier to clean them out of a catch basin than it is the pipe or the manhole attached to it. So the previous two videos were how to draw in your sanitary and your storm networks, lay out your catch basins, lay out your pipes, how to look for interferences, and then we sized and sloped them. When you have all the sizing and sloping done, Civil 3D does have what's called an interference check. So if we create an interference check, I want to check interferences between storm and sanitary. Storm, sanitary, interference check. Storm layout, sanitary layout. And we can do a 3D proximity check. So 3D will check around the pipe, whereas just a plain old interference check will only check the pipe dimensions itself. So if I want to check within a foot, so we're going to go 3.3 meters. So we want to check 300 millimeters around a pipe. I'm going to hit OK. OK, we're going to let Civil 3D think, and it will tell us no interference is found. However, if I come in and I now change, we're going to take this and we're going to bring this one up. My interference check is out of date. We're going to rerun it. And I haven't modified the pipe out to the north, so it's not going to find that as an interference. So just changing a few things here, modifying stuff. You can run interference checks. Anytime you do change something, Civil 3D will give you a warning here. We can put this, actually let's put this catch basin back so we can actually see what it looks like. So I'll rerun this. And now it tells us there's an interference. So we can right click zoom to. And it's just a little tiny purple marker where this interference is. But if we zoom out, we can see, okay, this pipe is going through this manhole. So Civil 3D will tell you that there is a problem and where it is once you run the interference check. In the next video, we're going to look at laying out our underground water.